Good morning. Welcome to the course on component-based software design, and this is the first lecture. So we start the course by giving a description of the contents of this course, and so this is basically a course on advanced programming by using C++ as a programming language, and since it's advanced programming, I'm assuming that you know at least some basic C. So you know how to write a simple C program and maybe also a little bit more complex C programs. We are going to quickly review the basics of programming in C in the first lecture, and the idea is not just to learn C, but to highlight the differences between C and C++. Okay? And in particular, I'm going to assume that you already know what is a local variable, what are pointers, what is a structure, and how to declare a function, how to call a function, what does it mean to call a function, and things like that. Okay? So in the first part of the courses, we are going to quickly review the basics of C++ programming. And so what does it mean, the concept of classes, object, and memory layout. I'm going to be pretty much precise because I want you to take I want you to be more confident with what is to programming in C++, because C++ is a complex programming language. So you must be very careful when you program in C++ to all different aspects of the languages. Okay, so we are going to talk a lot about pointers, references, and why references are much better than pointers. Then I'm going to explore the issue of copying objects, which is actually quite important. And finally, we start with inheritance, multiple inheritance, access rules, exception, and a little bit of templates and the standard template library. And I guess we are going to finish this part quite quickly. I would say in 4 or 5 lectures. Okay? And then in the second part, we are going to describe a little bit the new standard, because C++ recently went through a revision of the language, and specifically in 2011 there was the proposal of new syntax and new things in the standard. In particular, the introduction of the auto keyword, the introduction of lambda function, the move semantics, which makes things a little bit more complicated than necessary in some cases, some new standard template library classes, for example for concurrent programming with threads, or for automatic pointers. And then safety. We are going to discuss a little bit safety to exceptions. Okay, and then also, we are going to review very quickly some programming patterns in object-oriented programming, and in particular applied to C++. So the typical programming patterns are as described by the book of Gamma, Velicides, Johnson, and so on. And also we are going to describe the function objects, a little bit of functional programming in C++. I'm going to discuss template metaprogramming and template patterns. The fourth and fifth part, the fourth part is again on programming. It's quite quick because I'm going just to describe you how to do concurrent programming in C++. And this is quite interesting because today, with the wide diffusion of multi-core computers, multi-core processors, it's important to be able to program in a parallel way. So parallelize your program, and to do that you need to know what are the opportunities and what are the threats of concurrent programming, how you can do this in C++. And finally, the fifth part is going to be finally on software engineering. So I'm going to describe you the pillars of agile development practice. I'm going to introduce you along the entire course, but especially I'm going to talk about that in the last part, about test-based design and development, and the Scrum methodology, which is a methodology for agile development. So we are going also to, of course, to do some programming in this course, and so these are a few hints on how you can program in C++ on Linux and on Windows. So you have here. So I usually program in Linux, and I'm doing everything in Linux. So if you want to do like me, you just install Linux in your desktop or on a virtual machine in your computer. That's quite easy. For example, you can download VirtualBox for installing Linux in a virtual machine, and there you will find your G++ compiler. Please install the latest one, and then you can use any editor, or you can use some IDE for editing your projects. And however, at the very beginning, I recommend you to use command line tools. So you just use the terminal and an editor. And from Windows, of course, if you have access to Visual C++, that would be the best. Otherwise, I recommend installing Cygwin, and from there, basically, you have a sort of Linux-like environment where you can use exactly the same things you use inside Linux. Okay, and there are a lot of nice editors you can use for programming, and there is just a couple of them. Okay, so about books, I forgot to put the slides on books. So about books, let me see if I have it on my webpage. Just one second. So the books, what I recommend is to, of course, there are many books on C++, and it's very difficult to understand which one to do. And here we go. So reference books, one in which you can find free online is Thinking in C++ by Bruce Eckel. I think it's a very good book because it's very precise. It's a little bit big, like all books by Bruce Eckel. It's quite big, but it's a very nice book because it makes you think about a lot of little details on C++ which one cannot imagine. So please, you can download, you have the link here. Otherwise, of course, there is the Brian Strustrup book, C++ programming language, that you can use, and it should be a new version should be out recently with the new standard. Then concerning the sign pattern, there is this book, that's the most famous book about the sign patterns by Gamma, Helm, Johnson, and Blisides, which is called The Sign Patterns, Elements of Reusable Object-Oriented Software. Then what we have is about template metaprogramming. This is a little bit old, but still quite good. It's Modern C++ Design by Alexandrescu. Then we have some chapter from Herb Sutter, Exceptional C++. Then there is something about refactoring by Martin Fowler, and something about extreme programming explained, which is about agile programming. You don't need to buy these books, of course. Usually my slides are enough for everything, so please don't buy these books. And but these are reference books, so if you want to go deeper in the things we do in these courses, you may be interested in looking at these books or buying it. Okay, so these are not mandatory books, but they are suggested. Okay. Okay, so let's continue, and right now we will try to write a very simple hello world program in C++. Okay, just to show you how does it work. So I just opened an editor, and usually in Linux I use this editor, but you can use anything. And we just write our program. I will try to explain you something about C++ just by looking at this. Okay, so this is our first program, and the first thing it does is just prints hello world on screen. Okay, I hope you can see it, and we are going to type the command for compiling it, and this command is called G++, and we just type G++ and the name of the file, and we compile. And the compilation is end, and what it produces is a file a.out, which is an executable file that we can run like this. Okay, and this is going to print hello world on the screen. Very simple and very stupid. Let's go back and analyze the structure of this program. So we have include here, and this is a standard library. And this standard library is just for input output. And as you can see, differently from C, the C++ standard library don't have extension. So you don't have things like .h or .hppp in C++. You just have the name of the file. Okay, this is valid for standard libraries. Okay, then this one is an object cout that is used for doing output on the screen. Okay, this is the so-called standard output. And this standard here is just the fact, it tells you the fact that this object is defined within what is called a namespace, and in particular within the standard namespace. So all objects in the standard libraries are within this namespace standard. And this colon here indicate that this object is within this other namespace. Okay, this symbol is an operator and is used for telling that this string hello world should go onto this object and then out on the screen. We will understand a little bit better what is an operator later on. And finally, this object just marks the end of the line. So this will just do a return carriage and will mark the end of the line. Okay, you can avoid writing this standard here by typing using namespace standard, and this is telling the compiler that every time it meets an object, it has to look inside this namespace for finding it. Okay, so it's very simple. And G++ is the command for compiling it. So it takes this text file and produces an executable, and yes, you run it like that. Okay, not much to say here. Okay, so let's start an introduction to the C++ language by talking about classes. Okay, so here we have a few sentences that I found on internet, and I have to say that C++ is much more than object-oriented, in fact, and it's much more than classes. So the basic idea of Byron Stroustrup, when he decided the name of this language, was to take C and add two things. On one hand, he was adding object-oriented programming to C by using classes, inheritance, and so on. And the second plus stands for adding templates into C, so generic programming. So C++ has two plus because it comes with these two aspects. So let's start by describing the first aspect. So what is this object-oriented programming? So the basic idea behind object-oriented programming is to do data abstraction. So what do we mean by data abstraction? So basically in every language you find data types, okay? And so in C you will find integers, floating point, or characters, things like that. And so this is called primitive data types. And then more or less every language has a way to create a new data structure. In C you have basically two ways. One is the arrays, okay, which are sequences of objects that are together in memory, or you have structures. And with these two you can create more or less what you want. In C++ you have a little bit more support for it, because you have the notion of class, okay? What does it mean to create a new data type? So according to the basic theory of abstract data types, creating a new data type means defining basically three things. The first thing is how this is composed. So what is the domain of this variable? What kind of things it represents? The second thing is how do you build, how do you destroy this variable? And the third thing is how you can operate on this type. And if you want, the second and the third thing are basically the same. So basically it's operation on the type. Okay? As I said, you can do data abstraction in C and in almost any language. In C what you have is the notion of structure. For example, suppose that you want to write a program for doing mathematical calculations, and you want to support the notion of complex data type. So a complex data type is a simple data type which consists of two real numbers, okay? And so what you do is you create a structure which contains two doubles. The first part is the real part and then the imaginary part, okay? So we do a type def in which we define this structure complex, and we call this data type CMPLX, okay? And then we define operations. For example, how to add two complex numbers, how to subtract one complex number from another complex number, or how to compute the length, so the module of a complex number, okay? And so you write function for each one of these operations on the data type, okay? So what you can notice is that the language does not support too much the programming in doing this. So it just gives you the structure and then the notion of function, and that's it. And then you have to do everything by yourself. For example, you have to use pointers a lot when you do these kind of things, because you have to pass, okay, this object to the function, and the function has to modify it. So you need to use pointers. And this data has to be passed to every function explicitly, okay? Then another thing that you find is that you have name clashing. So if you have another part of the program in which some programmer uses a function getModule on a completely different thing, then you have name conflicts, because you cannot, in C you cannot have two functions with the same name, okay? The third thing is that there is no information hiding. So the programmer which doesn't really understand how to use the object can do whatever he wants, because he can access every single data of the data structure. Everything is permitted, okay? In C++ instead, what you have is much more support from the language in defining new data types. For example, what you would do in C++ is to define a class complex, which contains again a real and imaginary part, and then define the operation within the class. So you would define, for example, two constructors, which are functions to create the objects, a destructor, which is a function to destroy the object when it's not needed anymore, and then function for computing the real, the imaginary part, the module, to assign one complex variable to another complex variable, to sum, to subtract, and so on and so forth. Okay? And then the usage is much more natural, because complex in this case looks a lot like a normal primitive data type. Okay? You can define integers, but you can also define complex. In the same way as you define integers, you define complex. Okay? And then you can, as you can see here, you can assign one complex object to another one. You can sum, you can sum two objects to obtain another one, and so on and so forth. So it's much more natural to use this kind of syntax when writing a program, because C++ makes sure that there is a almost perfect equivalence between primitive data types and user-defined data types. Okay. In addition, C++ is a strongly typed language. The compiler knows which function to invoke just by looking at the type, and also it can make a lot of different compile time checks. It can check a compile time that everything is done in the right way. C++ is a much more loose language from this point of view, because types are important but not so much important, so you can go around the typing system very easily. C++ instead is much more strong from this point of view, because types are really important in C++ for many different things. Okay? So let's go a little bit more formally into the notion of class in C++. So class is the main construct for building new types in C++, as we have seen, and a class, I would say, is almost equivalent to a structure with functions inside. Okay? In C, if you have ever programmed in C, the programmer defines structures and global functions to act on the structures. In C++, instead, what you would do is to define classes and functions inside the class which act on the objects. Okay? So here we have the declaration of a class, my class. Then you have defined two things inside this class. One is an integer, so data, and another one is a function. Remember that at the end of the class definition you have to put a semicolon. A class contains members, so everything is inside a class is called member. And typically a member can be any kind of variable, and these are called member variables, or any kind of function. These are called member functions or methods. Okay? So you have B is a member variable, C is another member variable, get A is a member function. An object is an instance of a class. So a class is basically a type. Okay, so it's not an object, it's a type. It's a sort of way of defining new data types. Okay? An object instead is an instance of a class. So an object takes space in memory. And an object is created by calling a special function inside the class, which is called constructor. So a constructor is a function that has the same name of the class and has no return value. It may or may not have parameters. It is invoked in a very special way. You never really invoke directly this function. Okay? This function is invoked when you define an object of that class. So for example, here in this example you have a class and you define a constructor, my class. You notice that this constructor has the same name of the class and takes no parameter, and this constructor just prints cout constructor on the standard output. And then later on we can create an object of type class, and this object is created by this writing. Okay, so the constructor is invoked there. Of course, you can also pass parameters to a constructor, because a constructor is just a function, so it can take parameters. It can take parameters. So for example, here at this my class, I'm defining actually two different constructors. The first one takes one single parameters of type integer, and the second one takes two parameters of type integer. Okay, and then later on I'm going to define three objects of type my class, and the first one is an error because there is no constructor which takes no parameter. Okay. The second one instead we call the first constructor, and the third one we call the second constructor. Okay. C++ extends this kind of syntax also to primitive data types. So you can actually define a variable myvar, and this variable is of type integer and it's initialized to 2. And pi is a variable of type double and it's initialized to 3.14. Okay. So what are the rules for constructor? So if you do not specify a constructor, then a default one with no parameter is provided by the compiler. If you do provide a constructor, any kind of constructor, the compiler will not provide default one for you. Okay. And what constructors are for? Usually constructors are used to initialize internal variables, to give them initial values. Okay, so let's make an example. Let's try to compile and this in our hello example. Sorry, I didn't copy very well. Unfortunately, copying from PDF is a little bit difficult. Okay, I'm just writing very quickly. Okay, so this is just the definition of the class, very stupid. I'm not doing anything. Then I define two objects and then two variables in this way. Okay, so let's see if I didn't make any error. Then we are going to compile. I did some error. Oh yes, there was some spurious thing here. Okay, so I compiled and then I'm going to execute. As you can see, it prints first constructor, second constructor, hello world, and then 2 and 3.14. As you can see, these are global variables, so the constructor has been invoked before the main started executing, so before hello world. And this is valid in general. So all global variables are initialized by calling their constructors before the main starts. And this is valid for all global variables. Okay? And we can change it, of course. For example, we can move this inside. And now what we will see is that first constructor is printed, then hello world, then second constructor. Okay, so very simple. So constructor used to initialize members. Members can be initialized also through a special syntax, and in general this syntax is preferable when you can do that, because the compiler can catch some obvious mistake if you use this kind of syntax. Okay, so my recommendation is to use this syntax whenever you can. So this syntax is basically after the declaration of my class you put a colon and then the name of the members and inside parentheses their initial values. Okay, so that would correspond in our simple example to write like this. Okay, and in this case here we are going to write like this. Okay, so this is called initializer list. Okay, so it's the list of internal variables that you want to initialize, and so whenever you can, try to use this kind of syntax. Before going on, I would like to mention also that with the new standard you have also another way of initializing it, which is by using curly braces. So these kind of things. Okay, we will see later what does it mean. Let me try to see if it compiles. So if you run a G++ like that, it doesn't compile, because this is called extended initializer list and is only available with the new standard. So what you have to do is to specify this flag when running the compiler. Okay, so you compile like this, and now it compiles and it runs exactly like before. Okay, so these curly braces are called extended initializer list. We will see later on what's the difference between a normal initialization. Okay, so how to access members of an object? Well, if you have an object, you can access its member by using the same syntax as C. So by using the so-called dot notation. So in this case, for example, I'm defining a member variable of type integer a, and I can access it by using x.a. For example, x.a equal to 5. Okay. And I can call a function f by saying x.f, or function g by saying y.g. Okay, of course x and y are two objects of type myClass. Of course, if I do x.a equal to 5, this will assign 5 to variable a of object x, and it will assign 7 to variable a of object y, because every time you do an object, of course it's like the structure, you have a copy of every single member variable for each of this object. It is possible to implement the code of a function in a separate C++ file, or outside, in general outside the class declaration. Okay, so typically one would define the prototype of the function of a class in a header file. For example, a header file complex.h will contain class complex and will contain a declaration of all the functions without their implementation. And the implementation instead goes in a separate file, which is called complex.cpp. And you write like this. You write exactly the same prototype of the function that you find in complex.h, but before the name of the function you put complex : This : is called scope resolution. We have already encountered that when we have seen the standard namespace, and but it's also valid for classes. So basically it tells the compiler that the function module is within class complex. Okay? So most of the times this is preferable. You should, when you can, separate implementation from declaration. So interface specification goes in the header file, and the implementation goes into the CPP file. Okay? Inside a function, you can access internal members of the class without any additional scope resolution. For example, in class complex, we have two variables, real and img, okay, of type double. These are defined inside the class. So inside the function module, you refer to these two variables, real and imaginary, without any further specification. So temp is going to be the local variable, real and imaginary you will find into the class. And of course, real and imaginary refer to the current object. So when I call module on an object of type complex, this module function will act on the real and imaginary part of that object on which I'm calling the function. Okay? I don't know if any of you have done any programming, for example, using Python. This is quite different from Python. In Python, you are forced to use the self keyword for referring to the current object. In C++ and in Java, this is not necessary. So you just refer to the variables. Implicitly, the compiler is going to look first into the current function for local variables, for example temp, and then inside the class complex for member variables like real and imaginary. Okay? This operator, as I said, is called scope resolution operator and tells the compiler that the module is defined inside class complex. We can create local variables like temp. We can access member variables without any dot notation or arrow notation. Okay, so no problem. As you have seen, we can specify already access control for variables. So basically a member can be either private or protected or public. So the meaning is when a member is private, only member functions of the same class can access it. Other classes or global functions cannot access it. So for example, A is a private member variable. So when I define data as an object of type myClass and I want to print it, this one, the first line, cout data.a, will give you an error because A is private. I'm not inside a function of my class, so I cannot access A. And C instead is public, and it means that it can be accessed by everybody. So every single function anywhere can access it. So basically, the second line, cout data.c, is allowed. Okay? Protected has a special meaning for derived classes, and we are going to see it later on. So the default is private. So if you don't write anything, it goes to private by default. If you want to make it public, you have to specify public : and then from now on, all declarations are public. So int C, F, get A are all public members. So they can be accessed by everybody. And if you want to do another private data later on, you have to specify private again. And you can specify private and public as many times as you want. Of course, this is not really necessary. Most of the times, it's much better to group all private data into a single section and all public data in another single section. Okay? So modify, B and A are private, C, F and get A are public. Let's talk a little bit about scope. And scope, what is scope? Scope means which variable am I going to use. So in general, you can have a lot of variables having the same name in different scopes. And this is perfectly legal. It was legal in C, it's still legal in C++. It's a little bit a source of confusion, but when you get used to it, it's okay. So basically, here you have XX is a global variable of type integer. Then you have a class, and inside a class you define a member variable which is called XX. And then you also have a function f, and this is the implementation of f. And inside function f you have you are going to access XX. Which one you are going to access? So if you write XX equal to 5, the scope is first of all the function and then the class. So basically XX equal to 5 is going to access and to modify the member variable XX. If you want to access the global variable, what you have to do is to write : XX. This means go to the global scope and look for a variable XX. So : XX equal to 3 will modify the global variable XX. Okay? And of course you can use both. So XX equal : XX plus 2 means that the member variable XX is assigned the value of the global variable XX plus 2. So the final value is going to be 5. 3 plus 2. Okay? So why we want to use access control in programming languages and in C++? Well, the technique of declaring some of the members as private is called encapsulation, and is used in object-oriented programming to separate what is implementation from what is interface. The public part is the way the user of the class has to use it. So it's the interface to the rest of the program. The private part, instead, is the implementation of that interface by the class. So the idea is that when you work in a team, each group takes care of a different module. And to ensure that the integration is done correctly and without problems, first the programmer agrees on interfaces, then each one separately and in parallel implements the interfaces, and finally they integrate everything on the same program, and hopefully everything is going to work. Some people initially may think that private is the same thing as secret. Okay? That's not the case in C++. In fact, there are many people that complain that this private part is visible in the header file. In fact, when you define a class like this, you have to define the class and you have to define both the private and the public part. So the user that wants to use this class actually sees in the code that A and B are private. So it knows of the existence of this private. So private does not mean secret at all. Okay? Private means not accessible from other classes and not secret. And actually there is a very important technical reason why you have to declare the private part inside the class. Because the compiler needs to know the size of the object, so how much memory to reserve to the object in order to allocate memory for it. Okay? In a hypothetical C++ in which you could hide the private part, in that C++, the compiler could not know the size of the object, and so has no way to know the size of the object. So private part is technically very important for modular programming. Okay, so you have access rules in C++, and since C++ is a very liberal language, you also have exceptions to this. And the exception is with the keyword friend. So you can declare that another class is friend, and that means that that other class can access your private data. In this example, class A declares that class B is her friends. Okay? So class B can access the private data of class A and the private function of class A. In particular, here you can see that B defines a function f, and it can access y and f without any problem, because I declare that B is friend of A. Okay? Of course, the other way is not possible. B cannot declare that A is a friend and accesses data. Okay? It's one way. So, for example, A cannot access the private data of B, of course, unless B specified that also A is friend. Okay? So, friend means that B can access A, not vice versa. You can also restrict this friend to single functions and operators. Okay? For example, you can specify that the method f of class B is my friend. So only f within B can access my private data. Other functions within B cannot. Okay? So this is a more restrictive specification of friendship. And I can also specify that h, which is a global function, is my friend. Okay? It is better to use the friend keyword only when it is really necessary, because it actually makes things more confusing and it breaks the access rules. So actually, friend, I think in the long run should really be deprecated in C++. So we should avoid using friend as much as possible. Okay? It's a way to optimize things, but it's not very useful. So I would recommend to not use friend at all, unless you are very forced to do it. Okay? So as Scott Meyers, who is an expert of C++, which gives a lot of lectures on C++ around the world, so Scott Meyers said that friends, much as in real life, are often more trouble than they are worth. So let's try to not use friends. To make things more complex, you can also nest class declaration. So you can have a class, and within that class you can define another class. Okay? So class B is private to class A. It's not part of the interface of A, but only of its implementation, and I define B inside A. Okay? The fact that B is within A does not give to A any additional rights. So A is not allowed to access the private part of B at all. In particular, the function f within A cannot access member variable A within B. Okay? If you want to do that, as always, you have to use friend. So you have to declare that A is friend of B within B. But this is going to be too much complicated. So please, let's try to not use this kind of very complex nesting. Okay? Let's try to reduce to the minimum this kind of nesting. Okay, I'm going to go very quickly on the memory layout, and then we have 10 minutes break. Okay, so memory layout. So you should know this, but I'm going to recapitulate very quickly the rules for the lifetime and visibility of every variable in C++. So in C++ you can have global variables and local variables, and of course also member variables. Global variables are variables that are defined outside of any function, and their lifetime is the duration of the program. They are created when the program is loaded in memory, and they are deleted when the program exits. Okay, so global variable are the longer one. I mean, the duration is for the duration of the program. Local variables instead are defined inside functions or inside code blocks. And code blocks are just blocks of code which are opened by opening curly parentheses and closed by a closed curly parentheses. And their lifetime is the execution of the block. For example, when you invoke a function and you declare local variables inside a function, the local variable is created when the function is invoked and is destroyed when the function returns. Global and local variables stay in different memory segments and are managed in totally different ways. So, the memory of a program, you can distinguish 3 different types of segments. The global variables, they go into the BSS segment. It's called like that, I don't remember anymore the acronym for BSS, but it's basically the global memory. So it's where global variables go. Okay? Internally, this is usually divided in 2 parts. One for initialized data, so data that is initialized when it's declared, and non-initialized data. Okay? The size of this segment is statically decided by the compiler and is created when the program is loaded in memory and will never change during execution. So the size of this segment is fixed. Okay? Stack variable, instead, they stay inside another segment which is called stack. And this stack will contain local variables. And of course the size is dynamic, because every time you need to create a local variable, well, you need to enlarge a little bit this segment. Okay? It can grow, usually it grows always, and very rarely it shrinks. But usually it grows. Okay? And it depends on how many local variables are in the current block. And finally, what you have is the heap, which contains the dynamic memory. This is objects which are created dynamically. Okay, in C you will use things like malloc and free for allocating pieces of memory in the heap. In C++ you use 2 operators. They are called new and delete. We are going to see it very soon. Okay, so here is an example. So I have a lot of variables here. Let's see where they go. So A is an integer variable. It's global. So it goes into the BSS. B is also an integer variable. It is not initialized, but still goes in the BSS. Then we have function f. And function f, you can see a parameter, I, and then a local variable type double, d, and an array of characters, s. And these are all local variables. They all stay in the stack. Okay? And they are created when the function is invoked, and they are destroyed when the function returns. And then we have the main, and inside the main we define s and z, and these are also local variables. Okay? The lifetime of this variable is the lifetime of the program, because, well, the main is the main function. So when it's invoked, the program starts, and when it finishes, the program ends. So S is created upon startup of the program. It's destroyed when the program terminates. So the lifetime is the lifetime of the program. But anyway, it's local, so it stays on the stack. Okay, so we have a break now, and then we continue by talking about pointers and function overloading, and then we will start a little bit of an exercise which will continue tomorrow. Okay, so we have a break now, and it's now 11:56, so we come back at 12 and 5 minutes. Okay, let's have a break.